Hello, class. This is the Test 4 review. Test 4 has 15 questions. The first 5 are on Objective 13. The second group of 5 is on Objective 14. And that last group of 5 is on Objective 15. Okay, so this test will be out of 75 points. All right. So let's quickly go through these. Of course, you can always review the actual lectures for 13, 14, and 15 to get a more, a deeper, better understanding of the material. Here, I'm just going to go over a few questions out of each objective. So, like I said, number 1, 2, 3, 4, and 5 are on Objective 13. Some of the things that you guys need to pay attention to, of course, you have to solve by graphing for the first 5. So, remember we talked about 3 different ways of graphing: the table, the x and y intercept, and slope intercept. So use whichever method your heart desires, but make sure that you use it correctly. I told you guys that the slope intercept method is foolproof. It's really easy. Only thing about it, if it's in standard form, you will have to put it in slope intercept form, and that's where some of you are struggling. So for number 1 and 2, both of them are in standard form. For number 3, this second one here is y equals 3. And for number 4, the first one is x equals 4. So we're definitely going to talk about what to do in those situations as well. So let's jump right in. Let's look at number 3 and 4, because the same way we graph this first one here, this is how you will graph both equations for number 1 and number 2. So for number 3 here, now I'm going to do this several different ways just so you guys can see it done different ways. So for this first one, and I'm going to use different colors for each line. This first one is 3x minus 2y equals 12. Now, 12. If we look at 12, then we look at 3 and 2. These are multiples of 12. So what I'm going to do, I'm going to graph this by using the x and the y intercept. So I'm going to write my equation twice. On one of them, I'm going to plug in a 0 for x, and on the other one, I'm going to plug in a 0 for y, okay? The reason why we're doing this is because that is how we find those x and y intercepts. Remember, whenever we have an ordered pair where the x term is the 0, that is how we know that it's a y-intercept. Whenever we have an ordered pair where that y term is a 0, that is how we know that it is a x-intercept. So I plugged in the 0 here for x, so that means that this is going to go away. So we have negative 2y equals 12. So we divide both sides by negative 2. So y equals negative 6. Okay? So my first point, I could put a point at negative 6 on the y-axis. Now over here, I plugged in a 0 for y, so this is going to go away. So I have 3x equals 12. I divide both sides by 3. and x equals 4. So I can put a point at 4 on the x-axis, okay? Now that I have those 2 points in place, I can draw my line connecting them. So I'm going to do that. And hopefully by now you guys have your graph paper and a ruler so that this can look neat. A lot of you are not doing your markings correctly on your graph, so please make sure that you are doing that moving forward. So now I'm going to change my color to blue, and we're going to do our second line. So with this second line, it is y equals 3. So what we have to do is find 3 on our y-axis, and we do a line going straight through that. So this will be a horizontal line going through 3 on our y-axis, okay? So if we look here, this is where the red and the blue line intersect, okay? So remember, we talked about 3 ways to graph, but we also talked about 3 possible solutions in objective 13, okay? So when the lines intersect, we have a solution, and the solution is that ordered pair that's exactly at that point of intersection. If the 2 lines are parallel, meaning that they will never intersect, that solution is no solution, okay? If the 2 lines are the same line, that solution will be infinitely many solutions, and we also talked about how to get an ordered pair for that, okay? So this point here is 6, 3, all right? So what you will input in here, they already have the parentheses for you. So you would just type in 6, 3, all right? So this is how you graph using the X and Y intercept. For this blue line, we graphed it with a Y equals. So let's look at these two. Let's look at number 4. And we're going to look at another method that we talked about. So this first line, well, this first equation is X equals 4. So in order to graph that, and I'm going to do it on the same graph. Let me just get a different color. Let's do green. So we're going to do this one in green, and it's x equals 4. So we have to find 4 on the x-axis, and it's going to be a vertical line going through 4 on the x-axis, okay? Now let's look at our second equation. Let's do this purple. So with this equation, if I look at the 8, then we have 3 and 2. 3 and 2 are not multiples of 8. So what I'm going to do and that is something to look for when you are trying to find the X and Y intercept. If that A and B are not multiples of C, you will have fractions, which fractions are a bit more difficult to graph. So here, I'm going to subtract -3 on both sides. So I'm going to have -2y equals -3x plus 8. I'm going to divide everything by -2. So y equals 3/2x minus 4. And I'm going to rewrite that in case you guys can't see it. Okay. So in red, remember we graphed using the x and y intercept. Now in purple, we're graphing using the slope and the y-intercept. So when we look at this, we have to first identify what our slope is, which our slope is m, and our y-intercept is b. So we first plot -4 on the y-axis. Then we do our slope, which is 3/2. So we go up 3 and to the right 2. And we draw a line connecting that. So remember, in the first problem, we were working with the blue and the red line. Now we are working with the purple and the green line. Okay, so here we can see that the purple and the green line intersect here. I want to put a black dot there. They intersect here. So because we have a point of intersection, that means we have a definite solution. That is an ordered pair. And that ordered pair is 4, 2. So that is what you would type in for this particular problem. Okay, so we went over how to graph it if it's a x or y intercept. We went over how to graph it using the x and y intercept method and the slope intercept method. Okay. The other method we talked about was making the input and output table. You guys have that down, so we're not going to touch on that. If you have questions about that, definitely review the lecture. So this is the gist of solving by graphing, okay? Of course, remember, if we were given the equations in the same problem, the purple line and the red line, because they are parallel, they would be no solution because they would never intersect. So you would just have to write no solution, all right? If they turn out to be the same line, yes, that is infinitely many solutions. But in WebAssign, it is a certain way that we have to write that. Okay, so let's keep moving forward. So the next section of problems, we have 6 through 10, okay? Now, these are solved by substitution. And it looks like, at least on this version, at least one of the equations is already solved for that variable. So that's great for you guys. It's already done. So let's work 2 of these out so you guys can get the gist of that. Let's do 7, 7, and 8. So the first thing you want to do, pay attention to the one that's solved for the variable. This first one is solved for x, so that means that we're going to plug what it says that x equals. We're going to plug that in for this x right here in that second equation. So it does help to number your equations. So we're plugging the first one into the second one. So where that x was, that is where I'm going to plug 2y minus 15, okay? Now that y is the only variable that we have present, we can solve for y now. So once again, depending on what you plug in, it may look different. You are responsible to know what to do to simplify it. That's why we have worked on all of these objectives thus far, okay? So because this 3 is here, we have to multiply it by the 2y and by the negative 15. So we have to do our distributive property. So 3 times 2y is 6y. 3 times negative 15 is negative 45. Then we have our plus y. We can keep that. And we keep our equals 11. Now we have to look on each side and simplify. Remember, you want to simplify, combine your like terms on each side before you try to move things across your equal sign. So we got 6y plus y. That gives us 7y. We keep our negative 45 and we keep our equals 11. Now we need to add 45 to both sides. Okay? So we have 7y equals 11 plus 45, which is 56. So now we divide both sides by 7 to get y equals 8. Now, pay attention. After we have y, now we plug it back into this first equation. X equals 2y minus 15. We plug the 8 in here for y. So we have x equals 2 times 8, which is 16. So 16 minus 15 is 1. So we have a definite x and y, so that means our answer is the ordered pair 1, 8. All right? Now, with number 8, we have to do the same exact thing. Same exact thing. Only thing about number 8, this is our first equation and this is our second equation. The second equation is solved for y. So it tells us that y equals 3x minus 2. So in our first equation, where we see this y, we're going to plug in that second equation. We're doing the same thing, okay? So where it says y equals 3x minus 2, we're plugging it into this y. Now, we have plugged the y in, but this one doesn't look like the previous problem. And that's okay because we are supposed to know what to do. We're supposed to know how to simplify this. So we have 5x minus 2 times 3x minus 2 equals 5. So this negative 2 here has to be multiplied by the 3x and the negative 2. So we keep our 5x out here because we can't do anything with it at this time. So now we have to do our distributive property. Negative 2 times 3x is negative 6x. Negative 2 times negative 2 is positive 4. Then we keep our equals 5, okay? Now, before we get excited and try to start moving things across our equal sign, we need to first check the left and the right side of our equation to make sure that they are fully simplified before we start moving things across the equal sign. Over here, we have a 5x. Right here, we have a negative 6x, okay? So 5x minus 6x will be negative 1x, which is just negative x. We keep our plus 4 equals 5, okay? Now that everything is simplified, we can subtract 4 on both sides. So negative x equals 5 minus 4, which is 1. And we can't have negative x. So we either change the sign of the whole equation, multiply the whole equation by negative 1, divide the whole equation by negative 1. However you see it, let's do that. So I'm just going to say we're going to divide it by negative 1. So x will equal negative 1. Now that we have our x, now you can't pay attention to the first problem we did and plug it into the first equation because that will be incorrect. For this problem, we have to plug it into the second equation. We plug it into the equation that's already solved for y. So that way, when we plug in the x here, we can just work it out and it's already set up as y equals. So I'm going to plug in this negative 1 and 3 times negative 1 is negative 3. And then we have minus 2. So y equals negative 3 minus 2, which is negative 5. So since we have a definite x and a definite y, that is going to be our ordered pair. Negative 1, negative 5. Remember, WeberSign already has the parentheses here for you. So this will go on your paper, and in WeberSign, you will just type negative 1, negative 5. So I hope that the substitution method is clear for you all. Now let's look at addition or the elimination method. So with these particular problems, of course, we want to eliminate a variable. Some of these will be easier than others. Some of these you will have to multiply both equations by something. Some of them you may have to multiply only one equation by something. Some of them you may be able to just add them together and a variable will cancel immediately. But remember, all of our rules still apply as far as it being a definite solution, which is an ordered pair, no solution, meaning the lines don't intersect, or infinitely many solutions. Okay, so let's look at number 12 and number 13. So for number 12, let's label our equations again. So we have equation 1 and equation 2, okay? So the first thing we need to do is figure out which variable we want to eliminate. So if we look at our x's, we have 2x and x. So we want to think, how can we make this eliminate? So if we had 2x and negative 2x, that would add together to give us 0x, which is what we want. So that means we would have to multiply that second equation by negative 2. If we look at our y's, we have 3y and 5y, okay? So if we wanted the y's to cancel, we would have to multiply both of those. We could multiply the first one by 5 and the second one by negative 3, so we can get 15y and negative 15y. But why do that when we can just multiply the second equation by negative 2? So that's what we're going to do. So remember, when I say multiply the equation, that means that every single term in that equation has to be multiplied by that number. So just to write it out, we're going to have 2 times the x plus 2 times that 5y equals 2 times 3, okay? So that will be 2x plus 10y equals 6. Now we can add it to that first equation. So you can call this equation number 3. That is fine. Oh, and this was supposed to be a negative 2 because because the first equation has a positive 2, so we want it to be negative 2. So let me adjust that. Now we can add the equations. So we got 2x plus 3y equals negative 1, okay? So negative 2x and positive 2x is 0, which is exactly what we wanted. Negative 10y plus 3y is negative 7y. We keep our equal sign. Negative 6 minus 1 is negative 7. So because we have a negative 7, y equals negative 7, y equals 1. Now that we have that 1, we are kind of going back to doing substitution again. Now that we have y equals 1, we can plug it into whichever equation we want to. So I'm going to plug it into the second equation. So where that y is, I'm going to plug that 1 in. So it will be x plus 5 equals 3. Subtract 5 on both sides. X equals negative 2. Okay? So once again, we got that definite x and y. So our solution is negative 2, 1. All right, now let's look at number 13. For number 13, we want to look at our x's. We got 3x and 6x. If we wanted to make these cancel, we can multiply this first equation by -2. That will give us a -6x and a positive 6x, which will be 0. If we look at our y's, we have -y and 2y. If we multiply that first equation by -2, we will have positive 2y minus 2y, which will give us 0, okay? Another thing that you can notice, for our c, we have 11 and 22. If we multiply 11 by -2, we will have -22 and positive 22, which is also 0, okay? So in this case, when we multiply this first equation by -2, we will get -6 plus 2y equals -22. So when we add those together, we will get 0 equals 0, which is true. So when you are using the addition method, when you get two things that do not equal, meaning if it was like 3 equals 5, we put a line through it because that's not equal and it will be no solution. When we get two things that do equal, like 0 definitely equals 0, this is infinitely many solutions, all right? So the way that we write this solution in our WebAssign, we have to write it as an ordered pair. So let's take one of our equations. Let's take this first equation, 3x minus y equals 11. We have to put it in slope-intercept form. So we're going to subtract 3x from both sides. We have -y equals -3x plus 11. We can't have the -y, so we have to change the sign of everything. So that's y equals 3x minus 11, okay? So no matter what x or y we put into this first equation, it's going to be on the other equation because they are the same line. So we write this as an ordered pair. We write x as our first term, and then we plug in what the y equals. So we put one equation in slope-intercept form, and we plug in what that y equals, which is 3x minus 11. So this is the ordered pair, okay? So that is something very important for you guys to remember, all right? So that concludes the review for chapter for test 4, and good luck.